Venus. It's often called Earth's twin, but honestly, it's more like our evil twin, a total hellscape of crushing pressure and scorching heat. For decades, landing there has meant certain and very, very quick destruction. But what if we could actually build something that could survive? All right, let's dive into the incredible tech that might just finally tame the inferno right next door.
You know, it might sound a little crazy, but we are standing at the dawn of a new golden age for Venus exploration. After decades of being overshadowed by Mars, it looks like all eyes are finally turning back to our planetary neighbor.
And I mean that literally. There's an international fleet gearing up to go. You've got NASA sending Veritas to map the surface's topography and Da Vinci to plunge into the deep atmosphere and sniff out its chemistry. Meanwhile, the European Space Agency is launching Envision to create these incredibly detailed radar maps. It is a full-on scientific blitz, all slated for the late 2020s and early 2030s.
But hang on, here's the catch. Two of those are orbiters, and the one that does go through the atmosphere, Da Vinci, well, it isn't even designed to survive the landing. So that raises a huge question. With all this new focus, why does it feel like we're still treating the surface of Venus like it's completely off limits?
Well, the answer is pretty simple, and frankly, it's brutal. Venus just does not want visitors. The planet's surface is one of the most hostile environments in our entire solar system. Period. First up, let's talk about the heat. The average surface temperature is 465 degrees Celsius. That's about 870 degrees Fahrenheit. I mean, that is hot enough to melt lead. It's like being stuck inside a self-cleaning oven that's been cranked up to its absolute max setting permanently.
And then there's the pressure. It's over 90 times what we feel here on Earth at sea level. Stepping onto the surface of Venus would feel like being a kilometer deep in the ocean. It's this instant, bone-crushing force that would just pancake most machines like a soda can.
And hey, this isn't just a theory. We've tried this before. The heroic Soviet Venera probes back in the 70s and 80s, they actually made it down. But the longest any of them survived? Just a little over 2 hours, before the heat and pressure just cooked their electronics and crushed their hulls.
So here's the deal. If we're going to do real science, we can't just send a tourist that dies in 2 hours, right? We have to design a true survivor. We need a machine that can actually stick around for days or weeks, maybe even months. So what does a true survivor need? Well, this model here breaks it down into 3 crucial things. First, lifespan. Obviously, it's got to last longer than a movie. Then, mobility, because you have to be able to explore different spots. And finally, smarts. That's the autonomy to think for itself, because you can't exactly joystick it from Earth with that kind of communication delay. Real discovery, that happens when a lander has all 3.
And why do we care so much? Because a long-lived mobile lander could finally answer our biggest questions. For the very first time, we could use seismology to detect Venus quakes and map out the planet's interior. We could analyze different rocks to figure out if Venus ever had oceans. Oh, and it would give us our first ever long-term weather report from the surface of another world. How cool is that?
Okay, but to get to that kind of amazing, groundbreaking science, you need more than just the tough metal box. To get those answers, engineers have to completely reinvent the guts of the machine. They have to literally forge technology that thrives where everything else just melts. So, how in the world do you test something that's supposed to survive hell? Simple. You build hell right here on Earth. This thing you're looking at is the Glen Extreme Environment Rig, or GEAR. It is, basically, Venus in a can. It's capable of perfectly recreating everything: the crushing pressure, the insane heat, and that nasty, corrosive sulfuric acid-laced atmosphere.
Inside GEAR, engineers can basically fast-track evolution. They throw materials in to see what gets completely destroyed versus what actually holds up. You know, standard materials, even really tough ones, they just react with the atmosphere and crumble. The real goal is to find specialized, inert materials that stay stable not just for a few hours, but for months on end. And here is a perfect example of what failure looks like. On the left, you see a brand new antenna component, looking all shiny and pristine before the test. And on the right, that's the same part after just 60 days inside GEAR. The atmosphere didn't just tarnish it. No, it chemically reacted with the metal, causing this bizarre, destructive crystal growth that totally wrecked its function. Useless.
But out of all that destruction came a massive breakthrough. This right here is the hero of our story. It's a microchip, but it's not made from normal silicon. It's made from silicon carbide. They put this inside that same Venus simulator, and after 60 days, it didn't just survive. It operated perfectly.
This, my friends, is the key. High-temperature electronics that don't need a bulky, heavy cooling system. This is the technology that will finally unlock long-duration missions.
So, with this kind of game-changing tech now proven, what does the future of Venus exploration actually look like?
Well, this roadmap kind of lays it all out. Right now, in the near term, we're still in the era of short-lived landers. But in the midterm, thanks to tech like that silicon carbide chip, we can seriously start planning for landers that last for days. And then, the far term? That's when we can finally start dreaming big. We're talking mobile rovers, basically complex laboratories on wheels. And maybe, just maybe, missions that could bring a piece of Venus all the way back home to Earth.
Look, the ultimate goal here is to change the game entirely, to transform Venus from a place where we measure success in minutes of survival to a world we can explore with the same persistence and depth as we do Mars, with rovers doing real mobile science for years on end.
It's an incredible ambition, right? One that forces us to push the absolute limits of engineering. And it really leaves you with a final thought. If we can design and build machines that can survive and even thrive in the hellish landscape of Venus, what other impossible environments, here or on other worlds, can we conquer next?